This is chapter 9-1, similar right triangles. Please copy your cuts. Now, I'm going to say similar right triangles. This is probably one of the areas that, especially when you get to the trigonometry portion, was my least favorite when I was a student. But I'm going to give you some shortcuts that really help you understand and remember how to do this. That's really what I want you to do. Understand and know how to use this. I can't stress enough, the trig portion you will need. You are going to see it in Algebra 2. You're going to see it in Pre-Calc, Calc. You got to know the trig identities. But I will warn you when we get to that portion so that you know what you must absolutely remember. Not that all of it isn't important already. To begin, let's just recall about the definition of an altitude. Let's remember that when we have a triangle, such that we have here triangle ABC, the altitude is always going to be drawn from the vertex of one line to the opposite side, and it will form two right angles. So here's triangle ABC, and I'm drawing the altitude AD. Remember, altitudes are drawn from the vertex or from the angle to the opposite side, but it must make or form two right angles. I could do a second altitude if I were to draw from the vertex C over to the opposite side. Let's just say if I did that and correctly measured, of course you'd have to measure, this should form two right angles. I could also do an altitude from B over to the opposite side, AC, and form also another altitude. So, recalling altitude, what we're going to primarily look at in this particular case, in this chapter 9, is we're looking at this altitude drawn from a right triangle. So angle A was already a right angle, but I decided to draw the altitude from the right angle A. Okay? And when I drew the altitude AD, one special thing happens. I'm going to form three similar triangles. So now, of course, there are three triangles. The first triangle I had was triangle ABC. Now I also have triangle ABD. And I also have triangle ACD. Well, what happens is when I draw an altitude from the 90-degree angle, all three of those triangles will be similar in their leg lengths. All three will be similar in their leg lengths. Okay? That does not happen if I were to draw the altitude from C and form two right angles. Yes, this would still be if this were F. CF would be the altitude, however, it would not form three similar triangles. The only time I get three similar triangles is when I draw from the right angle and form an altitude. Then I will have three similar triangles. Let's go a little further. Theorem 9.1 is the altitude is drawn from the hypotenuse to the opposite side, or the 90-degree angle. On triangle here, let's slide this up just a bit. Here I have triangle ABC again. Okay? And Theorem 9.1 says if the altitude is drawn from the hypotenuse of a right triangle, then the two angles formed are similar to the original triangle and each other. But the key here is the hypotenuse, remember, is always the leg opposite the right angle. So the original triangle ABC, angle C is the 90-degree angle, therefore that automatically means that AB is the hypotenuse. So when I draw an altitude, which is now CD, I have three triangles. But because I drew this altitude CD from the right angle, all three of my triangles are going to be similar in length. Okay? It might be a 1-to-2 ratio, so that means that the giant triangle ABC might be 3-to-2 to the medium. The medium triangle is ACD. Okay, and then the small triangle might be a 1 to go from here's the large triangle, the medium triangle, and then the small triangle in that order. So to compare the large to small ratio is a 3-to-1 ratio. That means that the large triangle might be 3 times larger. Now that's not always the case, I'm just giving an example. The large to small ratio could be, I'm going to erase this too, the ratio could be 10, and let me erase this as well. This could be 10 to 4 to 1. We don't know. I was just giving an example when I did the 3. Okay, but let's just say that our ratio was from large to small is 3 to 1. Okay, well, I know from my medium to small it's going to be 2 to 1. Okay, and if I compare my large to medium, it's going to be a 3 to 2 ratio or 3/2 ratio. Okay, all right, let's go further into this here. Looking at that, Theorem 9.1 says that triangle CBD, the small triangle CBD, is going to be similar to triangle ABC on the large triangle ABC, and then triangle ACD, the medium triangle, is going to be similar to triangle ABC on the large triangle. And then of course, okay, if I compare the medium and small, that means that CBD on the small compared to the medium is going to be similar to let me slide over here, ACD. Now be careful, make sure you notice this. The first two I compared was triangle CBD, the small, to the large. Be careful, make sure you notice. Okay, C corresponds to A on the small. So on the small triangle, angle C, this itty bitty angle, where is that on the giant triangle? Pretend this was not here. Pretend that was gone. The altitude was gone. If I was just looking at the large triangle, where is that tiny itty bitty angle that we just had from the small angle? What corresponds to A? So I'm putting that altitude back in. So I see here on the small triangle CBD, C corresponds to A on the giant triangle. So I put them in the same position. The easiest one, what I see is next is B. I'm not going to do the easiest one next. B on the small triangle, CBD, that means this angle here, corresponds to what on the giant triangle? Well, if I took the altitude out again, okay, on the giant triangle ABC, it's still going to be B again because I didn't bisect that angle B. So B will correspond to itself. It will be the same on the small triangle when I put that altitude back, B on the small triangle, BCD, and B is still the same on the giant triangle as well, so they're both in the second position. Finally, angle D corresponds to angle C. How do I know that? That one's the easiest probably to find out. That's probably the one you can do first because they're both a 90-degree angle. Well, if I'm looking on the small triangle CBD, angle D is the 90-degree. Well, where is the 90-degree on the large triangle? Well, if I take away the altitude so you can see a little easier, A, B, C, you can easily see that C is the 90-degree, which corresponds to D on the small. Okay? And I do the same thing when I compare the medium triangle, ACD is similar to triangle ABC on the giant. So here, and I'm going to write this down so it's a lot going on here. This first one was the small compared to the large, and ACD is the medium. I was comparing the medium to the large now, and I'm going to put commas in here to separate them. So when I compare the medium to large, remember, angle needs to correspond to angle, and it says similar. They're not congruent. The triangle's legs are not congruent in length. They're similar. But the angles, remember, on a triangle, the angles will be congruent, but not necessarily the side length. So angle A on the medium triangle, ACD, corresponds to 1 on the large. Well, if I call out A first, and there's my angle A on the medium triangle, ACD, where is that on the large triangle? I'm going to remove the altitude again so it's a little easier to see A, B, C, D again. Well, A is the reflexive, it's itself. So A and A will correspond to one another on the medium and large triangle. All right, so I'll put the altitude back in. Looking again at the medium triangle, ACD, if I put in C, this angle here, and I'm going to use this right here, that angle there, where is this angle on the large triangle? That's on the medium triangle. Where is it on the large triangle? Let's delete it. What does it look like? It looks like it's going to be, and you know it's not angle A, we've used that, and you know what else is not there is the 90 degrees, so it can't be A or C, which means it automatically has to be B. B. Okay? And then finally, what's left is the two 90-degree angles. And on the medium triangle, if I put the altitude back in, on the medium triangle A, C, D, D is the 90-degree angle. And if I took that altitude out, you can see on the large triangle, if I'm tracing the large, you can see that C is the 90-degree angle, and there it is corresponding, excuse me, D and C correspond on the medium and large. Okay? All right, now when I'm comparing CBD, triangle CBD to triangle ACD, so I'm comparing now the small to the, medium. And there it is, small and medium. Now when I look at small and medium, remember we want to angle to angle, angle to angle. I want to correspond angle to angle. Well, if I start on the small triangle and I say angle C, this itty bitty thing here, where is that angle on the medium triangle? Okay? Well, on the medium triangle, if I take this and look over here at ACD, okay, we know it's not D because that's a 90-degree angle. Is that going to be this other portion here? The answer is no. That means it's going to be angle A. Okay? B corresponds to what on, B on the small triangle corresponds to what on the medium triangle? That means it's this one here. And then finally, the two 90-degree angles are D and D. All right, you can also cheat. Okay, let's go back to the small and medium comparison. Angle C was right here on the small triangle, CBD. And if I wanted to know which one on the medium that will be, you could cheat and just go, when you compare the small and the large, where was that angle C correspond to A? Well, look on here, where does A correspond to? If I go over here on A, it corresponded to A on that one, on the medium as well. Hopefully you understand what I'm talking about there, but if not, it's okay. Okay? And this is the first portion that we want to look at for three similar triangles that have been cut by an altitude.